Welcome learners. Today we'll see how to simulate frequency response analysis in PSpice software. So for that I need to go for PSpice software. So file, new, project. So series resonance. So first you'll take. So click on OK. So you'll get the PSpice window like this. Now I need to add the elements to the circuit. So first source, and then under source I need to select AC source, and then AC, click on OK, and then I need to have RLC. So I need to go for again Park library. Under Park library I'll go for analog. Under analog I need to add resistance, next inductance, and then capacitance. So now I need to connect all the three elements using wire. After connecting the elements, I need to place the ground. So I need to keep the values of R1, so 500 ohms, and then inductance 10 millihen 25 millihenries, 25 millihenries, and then capacitance as 0.1 microfarad. Now I need to go for simulation profile, new simulation profile, create. So here I need to go for AC sweep analysis. So I need to change the frequency from 0 to infinity or to a maximum point. I need to go for AC sweep analysis. So what is the starting frequency? I'll take it as 100. End frequency, and then points. So here how many points I need to take in between 100 to 10,000. So I need to take it up about 1000 points, and then click on apply, and then click on OK. Now first I'll give the values of voltages. So 10 volts, and then so if I simulate this, I'll get the window here. Now I need to add the waveform here. So from 100 hertz to 10 kilohertz. So I am taking the current value I of R1. So if you observe here, at what I need to know at what frequency I have got the maximum value. So for that I need to go for toggle cursor, and then peak cursor peak. After identifying the cursor peak, I need to click on mark label. So the resonant frequency we got it is 3.184 kilohertz, and the current at that point is 20 milliamperes. So this is how you need to check theoretical calculation whether whatever the frequency you calculated using the formula is obtained here or not. Whether you need to cross verify whether both the theoretical values and the practical values matches or not. So this is how you need to implement series resonance in series RLC circuit. Clear? Similarly, this can be applied for parallel RLC circuit also. For that, I need to connect the elements L and C in parallel. So therefore, according to the parallel resonance. So again simulate. So I'll check the current value I of R1. So now at what frequency I'll get the least value, I'll check. So here I need to go for cursor through. So now if I go for cursor through at 3.184 at 13.80 microamperes.